Hi, today we're going to talk about mass to mole conversions. This is on page 2 of your packet. We're going to do questions 7 and 8 together. So far you've done mole to mole, and you've done mole to mass, and now we're doing this mass to mole, which is just the opposite of mole to mass. So the first thing we need to do is balance our chemical equation. So we have 1 aluminum and 1 aluminum. Copper has 1, copper has 1. Our chlorine has 2 on the reactant side, and on the product side it has 3. So in this case, find the least common multiple of 2 and 3, which is 6, and then multiply that subscript by whatever is going to equal 6. So 2 times what equals 6? That would be 3. And remember, whenever you use a coefficient, you always put it in the front of the formula, and it goes to everything behind it through multiplication. Over here, 3 times what makes 6? 2. And when we do that, we've now unbalanced the metals, the copper and the aluminum. So here we have 3 coppers, here just 1, so go ahead and put a 3. Here we have 2 aluminums, over here we have 1, so let's put 2 right there. And now our equation is balanced. Okay, first question on A is, what is the molar mass of copper 2 chloride? Remember when I'm saying copper 2 chloride, that means that copper originally had a +2 charge, indicated by a Roman numeral. And so that's why I'm saying it as copper 2 chloride. Okay, first thing is mass. So mass we're going to get from our periodic table. We're going to look at the masses of copper and chlorine. So copper's mass is 63.55, and chlorine's mass is 35.45. So let's go ahead and put them down. 63.55 for copper. And notice there's only one of them, one atom in our formula. So that's just going to stay at 63.55 grams. For chlorine, however, we've got 2 atoms. That's what that subscript means, how many atoms we have. So we're going to take 2 and multiply it by the mass of chlorine, which is 35.45. That's going to give us 70.90. And then we just add up these 2 values. So we're going to end up with 134 grams of copper 2 chloride. And remember that anytime you have a mass, that mass is always equal to 1 mole. So this now is equal to 1 mole of our copper 2 chloride. So right here, we're going to have 134.45 grams is the molar mass. Okay, second question B. What is the mole ratio of aluminum to copper 2 chloride? So remember, when we're doing mole ratio, we always look at the coefficients. So the coefficient for aluminum is 2, so we'd write 2. The coefficient for the copper 2 chloride is 3. So the mole ratio is 2 to 3 for aluminum to copper 2 chloride. Okay, last part of the question is C. So how many moles of aluminum must be present to react with this 2.85 grams of copper 2 chloride? So when we do this problem, we need to break apart the question. So first thing, it's asking us to find moles of aluminum. And then it gives us what we're starting with, which is this 8.25 grams of copper 2 chloride. So let's write an outline. So we're starting with grams. So I'm going to put down here grams of copper 2 chloride. Now we can't just automatically go to moles because we have to be in the same unit. So now what we're going to do is we're going to go from grams of copper 2 chloride to moles of copper 2 chloride. And now, because we're in a mole, we can do a mole ratio and go to moles of aluminum. Okay, so whenever we go from grams to mole, remember we're going to use our molar mass. So this is our molar mass right here. And we already figured that out in step A. So 134.45 grams of this copper 2 chloride is equal to 1 mole of our copper 2 chloride. Then we're going to go from moles of copper 2 chloride to moles of aluminum. So whenever we do that, we're going to use a mole ratio. And we already figured that out in step B, which was 2 to 3. 2 moles of aluminum to 3 moles of the copper 2 chloride. Okay, so let's go ahead and write down our fence using this information. So again, we're going to start with this 8.25 grams of copper 2 chloride. Write our fence. Remember that whatever unit and substance we have here, we want down on the bottom, because when we divide, it cancels out those units. So we're going to put our grams of copper 2 chloride here. And our grams is from our molar mass that we found. So this is the 134.45. And that mass is always equal to 1 mole of the same substance. Notice this is both copper 2 chloride. Now, notice how we're following along with this fence. We started with grams of copper 2 chloride. We're in moles of copper 2 chloride. And now we're going to go to moles of aluminum using our mole ratio. So since moles of copper 2 chloride is here, we're going to put it down here. And according to our equation, we have 3. So remember this ratio right here? So I'm going to put 3 moles of the copper 2 chloride. And then we're going to find how many moles of aluminum, which is 2. So 2 moles of aluminum. Okay, now our units and our substances should cancel. So grams of copper 2 chloride, moles of copper 2 chloride, and now we're left with moles of aluminum, which is what we want. So now it's just time to do the math. So when we do the math on here, a couple different ways to do it. I personally like to multiply across the top and then divide by the bottom. So I would put in my calculator 8.25 times 2, because there's no reason why we need to multiply by 1. It means the same thing. Then I divide by 134.45, and then I would divide again by 3. And I would put that in my calculator. When I do that, I get 0.041 moles of aluminum. A second way that we can plug this in is, again, we're going to multiply across the top. So we're going to do 8.25 times 2. And then I'm going to divide by the bottom, but I'm going to put these in parentheses, 134.45, and I'm going to times that by 3. But notice if I'm going to use multiplication on the bottom, I have to use parentheses because of order of operations. And you're going to still get the same answer. So the answer is 0.041 moles of aluminum is our answer. So that means that if we have 8.25 grams of this copper 2 chloride, like let's say we go into our little chemical closet and that's how much we have, then we would have to have a minimum of 0.041 moles of aluminum to make this reaction work. Okay, now let's do our question number 8. Okay, so question number 8, I'm going to go ahead and erase this. Okay, I'll have you look at this. Question number 8 is right there. I'll keep that out so you can see that. Okay. So the first thing we're going to do on this one is go ahead and balance it. Okay. So question number 8, CH4 plus oxygen, so this is methane plus oxygen, goes to water plus CO2. So first thing is carbon, 1 to 1. Hydrogen, we have 4 and 2. So what times 2 makes 4? 2. Again, we're going to put that in the front. Now our oxygen, we have 2 on the reactant side. On this side, we have 2. That's going to distribute. Plus 2 is 4. So 2 times what makes 4? 2. And that didn't unbalance anything else. So now that's our balanced chemical equation. So first question on here is what's the molar mass of methane? Methane is CH4. So again, we're going to use our periodic table. Carbon equals 12.01. Hydrogen, there's 4 atoms, so we're going to take 4. We're going to multiply it by its mass, which is 1.01. So now we're going to add up 12.01 and this 4.04. So we're going to get 16.05 grams of methane. Our next thing we're going to do is B. B is saying what is the mole ratio of water to methane? So here we're looking at water and methane. So our ratio would be 2 moles of water to 1 mole of methane. And then our last question is asking us how many moles of water are made from combusting 16.5 grams of methane. So we're going to start with what we're given, which is this 16.8 grams of methane, and methane is our CH4. And we're trying to find, remember, our moles of water. So again, we're going to use this outline. Grams of methane is going to go to moles of methane, which is going to go to moles of water. Okay, so if we've got grams of methane here, we need it down here. So we're going to put grams of CH4. This comes from our molar mass, which is 16.05, and that always equals 1 mole. Then we're going to go do our mole to mole ratio right here. So right here, 1 mole of our methane. That's equal to 2 moles of water. And then we're just going to multiply across the top and divide by the bottom. So I'm going to go ahead and put in 16.8 times 2. Then I'm going to divide by 16.05. And I get 2.09 as our answer. So 2.09 moles of water is our answer. So in this problem, it's saying that if we have 16.8 grams of methane, how many moles of water can we make? We're always going to assume that we have enough of our other reactant. And so with that assumption, we can make 2.09 moles of water. Now you can go ahead and do page 5 of your homework. On page 5, you can do questions 1, 4, and 6. And I hope that helps. Have a great day.